This is the Lexsolar Pv Professional, our experiment system for the study of photovoltaics on the level of vocational education. For safe and easy handling of the equipment, the components are clearly laid out in a practical case. We want to perform an exemplary experiment simulated with the components of an autarkic system. Autarkic systems have, in spite of many large-scale power grids, great importance for the supply. For example, they are essential for remote weather stations and mountain regions. For the simulation of such a model, we need a base unit, the solar module with base, the motor module, capacitor, the deep charge protection module, the series regulator, and the lamp and short circuit plugs. Now we have all the equipment to assemble the experiment. First, we need the base unit. It has a ground line and provides slots for up to 4 modules which can be connected in series or parallel. The supply element in our autarkic system will be the solar module. For the construction, we put it on its base and connect it to the base unit. For the illumination of the solar module, we use the lamp. It is frontally aligned before the solar module. With our experiment, we want to gradually illustrate the role and necessity of individual components. For our first part of the experiment, we put the motor module on the base unit and connect it to the solar module afterwards. In this way, we now have a circuit consisting of a producer and a consumer. If we turn on the lamp, the illuminance on the solar module is so high that the power generated drives the motor. If we turn off the lamp again, the motor stops turning. In reality, this means that at low light intensity, as in the night, the necessary supply is no longer guaranteed. To ensure a steady supply, we need an energy storage. In our experiment, the energy storage is going to be represented by the capacitor module. This we place between the producer and consumer. Now we turn on the lamp again and connect the motor with the 2 other devices using a short circuit plug. The motor turns over, and if we now turn the lamp off, the capacitor replaces the solar module as an energy source and the motor continues to be driven. For safety, we must ensure that the capacitor is not overcharged by the solar module, whereby it could be damaged and fail. For this, we are using a series regulator. The regulator is a so-called on-off controller which disconnects the capacitor from the solar module when it reaches the preset charge voltage. The solar panel is only connected again when the voltage is under the threshold. The control LED of the series regulator is on while the capacitor is charging and turns off when the charge end voltage is reached. As storage media must be protected against overload, so must they also be protected from excessive discharge. Deep discharges reduce the lifespan of the batteries. In order to counteract this, we use a so-called deep discharge protection. It guarantees that the voltage of the storage never goes below a certain voltage. If the LED of the deep discharge protection lights, the connection is closed to the motor and a current flows. If the LED stops lighting, then the discharge voltage is reached. Our model of an autarkic grid is now completed. In the following, we could now, for example, still measure the charge and discharge voltages or perform some scenarios. In addition to this experiment, 25 other experiments on photovoltaics can be carried out with the Lexsolar Pv Professional. In the accompanying instruction booklet, you will find the different experimental setups and implementations. There are also possible evaluation recommendations in the experiment handbook. In the case there are, for example, 3 medium and 3 small solar modules. With these, the behaviour of voltage, current and power can be investigated in practice-relevant series and parallel circuits. To regulate the illuminance of the medium and small solar modules, there are 3 lighting modules. You can insert up to 4 bulbs and produce a variety of light levels from different connected voltages. In the experimental setup, the lighting modules are placed directly on the solar modules. A problem of photovoltaic systems is due to the series connection of solar modules shading, causing significant performance degradation. The diode can show how efficient photovoltaic systems mitigate this problem. For the quantitative measurement of voltage and current, there are 3 multimeters in the case. These can be connected to the modules or base unit via cables. Additionally, there is a temperature sensor. Temperatures can be measured with this through the multimeter. In addition to the motor module, there are many more consumers. These include different ohmic resistances, a light bulb module, and an LED module. The most important consumer is probably the potentiometer. With this, IV characteristics of the solar module and its dependence on the illuminance and temperature can be examined. Furthermore, there is an MPP tracker that maximizes the performance of the solar module. It can be either manually controlled or run in automatic function. In addition to the series regulator, the suitcase offers further charge controllers with the shunt and the PWM regulator. Their manner of functioning can be studied and compared experimentally. In the experiment system at last, a DC-AC inverter is included, which makes it possible to illustrate characteristic properties of the AC voltage using the gauges and consumers. On the accompanying CD are experimental instructions and background information for the teacher, and contain experimental protocols for the students. We wish you lots of fun experimenting.